Hi, everyone. Thank you for that introduction, Yuan, and thank you to you and the Geographic Data Science Lab for the invitation to talk about some of my work. It's good to see some familiar faces, if only virtually. So I want to start by giving a bit of background about myself and the kind of longer term epistemological aspirations of my work before I delve into the research at hand. I have degrees in economics, architecture, urban planning, and work experience in data science. So when I talk about the questions and methods that shape my work, I usually show some kind of Venn diagram like this. And aside from my primarily quantitative empirical research now, a lot of my previous work draws from speculative design, critical cartography, and ethnographic research methods. However, this has meant for a long time that I felt a bit of a disciplinary nomad. The reason why I'm interested in these different ways of understanding is because I find each by themselves unsatisfactory frameworks. But recently I've been thinking that perhaps these approaches can somehow fit together in a kind of connected dialectical manner. So the more I understand the work of urban planning theorists, especially feminist planning theory, the more I found a home in planning, the ultimate, I think, interdisciplinary field, which respects and embraces a pluralistic approach to knowledge creation. So I'm just going to read this quote here from Leonie Sandercock and Anne Forsythe. So feminists argue for connected knowing, by which we mean something like the head and the heart, reason and passion, rationality and politics. In other words, an effort to transcend the dualisms and exclusions of positivist epistemology. So at its core, I think about my research through these three connections. How can urban theory allow us to ask better questions using data science methods? How do these methods then shape theory? On a more disciplinary level, how have deeply embedded discriminatory housing practices in history surfaced in contemporary neighborhood change? And how can these contemporary conditions be a key or evidence to understanding how these processes unfolded over time? And lastly, and what I'll focus on today, how can we approach long-standing questions such as race and class stratification and segregation through a new lens of big data? And how can big data reshape the way that we talk about these topics? Of course, these are simplifying connections, but I think they're useful frames. And so my main research actually focuses on the impact of historical discriminatory housing practices implemented in the American federal government during the mid-20th century. So if you'd like to invite me back, I'd be happy to talk about racial capitalism, the proliferation of gentrification practices, displacement due to urban renewal, and widening social inequality. But for today, I'll be presenting a secondary research interest on how we measure segregation. So I'm sure we all think that our day-to-day neighborhood context can influence our lives in many ways, from having a more subtle background influence to providing opportunities for social interaction. There's a whole part of urban sociology that studies the effects of neighborhood context and how this impacts income, crime, health, educational outcomes, and intergenerational effects, amongst others. And much of the research here centers on race and class diversity. And I should say that obviously this is also an area of research in adjacent fields like human geography, political science, and planning. So central to the neighborhood context is the social context and how this translates into potential social interaction. Most of the quantitative studies in this area still relies on the residential context from census data as a proxy for the neighborhood. And it's no surprise as this is the data that's typically available to researchers. However, does this sufficiently address our actual day-to-day social exposures? What about our other activities such as school or work or leisure? So key to this question is the idea that social exposures are dynamic and therefore potentially ill-represented by a static measure such as the residential context. And revisions of traditional notions of residential diversity have developed a more egocentric and therefore spatially and temporally dynamic characterization of the activity space. So Kwon, in her 2013 paper, highlights the spatial temporal variation of daily activities. Colton et al. Talk about how people don't think about these somewhat artificial administrative boundaries. Browning and Stoller emphasize that it is ultimately this exposure to neighborhood context that influences outcomes. And Jones and Pevley have found that there's a lot more heterogeneity in the activity space landscape than what's actually, than what's implied by the residential context. And just because we can measure context, how do we know that it's connected to the social interaction that a lot of researchers actually theorize about? So here's a mechanism that George Galster and Friedrichs proposes in which a diverse social context is created by some policy, which engenders the day-to-day social mixing of people, and that produces social contact and a desired outcome of this particular policy. However, despite being theorized, we don't actually understand this mechanism very well. In fact, the qualitative studies suggest there's usually less interaction than what's implied by the residential context, while the quantitative studies often say that there are clear social benefits to residential context, so something must be happening. And of course, this isn't just a theoretical division that academics like to discuss. There are important housing policy implications and understanding a diverse social context and how this translates into opportunities for diverse interactions. Almost all of our affordable housing policy in the US is now premised on the deconcentration of poverty. And that mixed income housing and by extension, mixed race housing can improve socioeconomic outcomes through, amongst other channels, diverse social interactions. So many housing advocates will also suggest that these mixed income housing policies are a mechanism for gentrification, and that the neighborhoods which are gentrifying due to these policies, in fact, do not see social interaction between different communities. So what Robeson and Butler call this tectonic social relations, a parallel and non-integrated communities that kind of overlap each other physically, but there are no, there's actually less social interaction than what's implied by the residential context. So then in the study, I also ask whether this is true, as some of the case study research suggests, that the opportunities for interaction are less diverse than what's implied by the residential context. And so this research also asks how we can use new data sources to explore these questions. And in particular, I propose that we can use mobile application GPS data to study these kinds of questions, as this fairly new data source is much more accurate than previous types of data and is a reflection of where people actually are throughout the day. And as far as I can tell, no one's really used this mobile app data to study racial diversity or segregation, since this data has really only been available in the last few years. So the data set that I'm using is has about 40 million pings per day in Chicago. I'm studying Chicago, and about 300,000 users before any data processing. Here I'm using daily pings from July to October in 2019. And for each ping, I get a lat long, a measure of accuracy for that ping, a timestamp, and a user ID. The median accuracy of the data after pre-processing is about 12 meters per ping. And so through my process of finding home locations, I'm actually left with about 89,000 residents in the final data set. And before I continue, I just want to talk about best practices and ethics of using this data. So first, in the US, I think there should probably be federal privacy laws that protect consumers and better regulate the availability of this data. I'm ultimately using a much smaller data set than the original, and I think it's sufficiently representative. So I don't think there are necessarily any harms to having less data. And I think that, if we think that there's no great selection bias to who opts in or that's the selection bias can be modeled, I don't think the data's usefulness would suffer from more regulations and likely fewer people in it. And secondly, the provider gave me a list of location types such as schools, hospitals, prisons, and homes that I can't explicitly single out in the study. And then third, I'm also deliberately obscuring and aggregating the home locations that I show in presentations and anything that I publish. So you'll never see me show an exact home location on a map. All right, so going back to the data. First, there are a series of steps that I undergo to clean and summarize the data, which is actually the most important aspect of this project, I think, because the data can be very messy without these steps. I'm not going to go through all of the steps in detail, but I'll just say the most important part was the removal of these pings from major roads, which there are a lot. So it's these transit points exactly that I don't want to include in my study here. So I remove the points from that are within a 60-foot diameter buffer around major streets, and I also remove points that have velocities greater than 24 kilometers. So I realize I'm using two different measurement systems here. And then secondly, I also, when estimating the home locations, I look at the land use of Chicago, and I'm only going to associate home locations to areas that are plausibly areas where people can live, so residential areas. So in this study, I'm looking at basically 3 social spatial contexts to derive a residential, observed, and interaction exposure. I'm using census data to measure the residential exposure and the mobile app data to measure the observed and interaction exposure. So I'll just quickly describe what each of these 3 exposures are measuring. So the residential exposure assumes that your exposure is what is implied by your place of residence according to the census. Not only does it not measure the realized day-to-day context, but it's only granular to the block group level. So this is an equally likely scenario, and arguably this condition has a different exposure level than the previous one that I showed. The observed exposure is all the activity that we see in a particular census block group. So realistically, the social context looks something more like this. And finally, the interaction exposure introduces a space-time component to ask when people actually have the opportunity to come into contact with one another. So at 10 a.m., the neighborhood interaction context can be this. At noon, it could look like this. And later in the day, it could, again, be different. And one thing I should also mention is that the observed and interaction exposure measures also take into account the people from other parts of the city visiting the neighborhood, which the residential exposure does not. So the measure that I'm using to understand exposure to racial diversity is derived from the probability that any 2 randomly selected people in a social spatial context are not from the same racial group. And it's this change in the social spatial context that changes this measure across the 3 different measures. And I think I have a duplicate slide. So what does this mean exactly? So the measure that I'm using is based on the Simpson index, which again is the likelihood that if I randomly select two people, they're not from the same racial group. And it's agnostic to boundaries of area units and the number of groups in the comparison. And all of these exposure measures have a range from, in this case, 0 to 0.75, because I'm subtracting essentially self-exposure or isolation from 1. So for the residential exposure, I'm just looking at the exposure for the residents in the area for a particular Black group using 4 racial groups: Asian, Black, white, and Hispanic. So, and the observed exposure is then just the exposure in the Black group for all the stays within that Black group across the entire time span. So though these are observed and spatially dynamic, it's still a static measure as it doesn't consider time. And I'll talk about these weights in a moment. And then finally, the interaction exposure calculates the exposure of at least 2 people who have an overlap in space and time. And then for ease of comparison, I aggregate these exposures to the Black group level. All right, so my hypothesis is basically that the observed exposure will generally be more diverse than the residential exposure on the census Black group level, because it captures a wider range of activities and contexts and people throughout the day, including the residential context. However, based on previous work, I hypothesize that the opportunities for interaction are actually less diverse than what the residential diversity measure suggests. And so how am I calculating these individual activities and states? I think unlike most cell phone data studies, I don't actually want to look at all the data, just those times during the day when someone is likely to be staying in place. The idea being that people in transit, likely in cars in Chicago, are not going to meaningfully contribute to your social context. And you're probably not going to have a lot of opportunities to interact with people while you're in transit. So for each user's daily trips, meaning a segment of pings that are within 5 minutes of each other, I find the points that cluster in space. And how this clustering is done is dependent on whether I'm looking at the user's home location or just the activity space. But for the home location, I cluster using a 150-meter DB scan between 1 and 5 a.m. And for state locations, I'm using a much smaller radius of 10 meters in DB scan, and the clusters and the pings have to be within 5 minutes of each other. And then the centroid of these points are then registered as the actual location that you serve. So to derive the home locations, I'm actually using the highest count cluster for each user between 1 and 5 a.m. So say I have these 5 potential home location points, only these 3 will be clustered. And then if this is the highest count cluster, this point here, this centroid, will then be the registered home location of that particular user. So I should also just mention that kind of due to the nature of this type of analysis, I'm only studying potential residents for Chicago, which is intended to kind of be able to measure the parallels between these new exposure measures and residential exposure. And then when there is at least an overlap of 2 people in space-time, that is when they are within 10 meters and 5 minutes of each other, this is counted as an interaction opportunity. So overall, I only found about 30,000 interaction clusters across the entire period, with a typical range of about 2 to 4 people within each cluster. So it's actually not a lot of interaction opportunities and not a lot of people. So once I have these home locations, I can then join them back to census block groups. and check the representativeness of the data. Then after some filtering for extremely high density cell counts at all hours of the day, meaning like mainly at airports and downtown. So removing those, the correlation between the log mobile app population density and the log census population density is about 0.83. And modeling this relationship also produces decent adjusted R-squareds of about 80% to 84%. And so actually, when I tried to model the mobile application population density here, I find that both Black percentage and higher education percentage positively predicts mobile app population density. And so this is actually something that I will control for in my final population density model. So I'm using cell population density, as well as Black and higher ed percentages as predictors. So actually, without these socioeconomic or demographic predictors, I still get unbiased estimates, just lower R-squareds. But I think importantly, what these two charts are meant to show is that you can produce unbiased estimates of population density with fairly decent adjusted R-squareds. But then ultimately, the population might be unbiased. On average, there's still going to be some unexplained variance, and each particular census block group may be over or underrepresented using your predicted population. And so I'm actually going to reweight the population based on the ratio between the actual and the predicted population. And you can see here that most of the weights are between 0.5 and about 1.5, obviously with the mode at 1. And these charts here show the resulting distribution of the population, demographic, and socioeconomic profiles of the census data, which it's a little bit hard to read here, but it's this red line versus the mobile application data, which is this blue line. So overall, I think it looks pretty good in terms of the distribution, especially in the race and ethnicity categories, which is ultimately what I use to calculate the exposure measures. And then lastly, the interaction exposures are calculated based on a probabilistic demographic profile for each user. So if somebody comes from a census block group that's 75% white, 10% Black, 5% Asian, and 10% Hispanic, this maps onto their probability of being a particular race. And I think Chicago happens to be a good case study for testing this method because it's quite racially segregated. So I think this means that there's actually going to be a lot more variation in the distribution of exposure measures than if you had a more kind of homogeneous racial population. It's also the city that I'm focusing on for some of my other work. All right, so kind of with all that said, here is what the results look like when I calculate the residential exposure and the observed interaction exposure. This chart here is showing the residential exposure for Chicago. I think that for those of us who are kind of familiar with the racial breakdown of Chicago, actually you can kind of see in this previous map here, most of the city, most of the south side of the city is, and the west side of the city are Black. Blue here are the kind of predominantly Hispanic populations. This tiny red area are the predominantly Asian neighborhoods, and then brown here is the predominantly white neighborhoods. So it's quite distinct. And I think that this pattern, so when we look at the residential exposure, this pattern is basically replicated. So there's the south and the west sides of the city are quite racially segregated, while the northwest sides of the city are much more diverse. And these charts here show the difference between the observed measure and the residential exposure, with blue being indicating that the observed or interaction exposures are higher than the residential exposure, and then the red being lower. So again, the south side in the residential exposure, you can see that it's a large swath of low exposure due to racial segregation. Hyde Park is probably a zone of exception. We can see that in the middle chart here, the observed exposure is generally higher than the residential exposure, with kind of some gray areas showing that the observed exposure is roughly the same as the residential exposure. So this confirms the first part of the hypothesis. What I think is also interesting is that the south and the west sides of the city stand out, meaning we're probably underestimating the exposures to diversity in these kind of residentially segregated neighborhoods. And then the interaction exposure is much more heterogeneous, which actually confirms some findings of previous researchers. Nevertheless, I think the south and the west sides of the city are still, we can see that they're still not diversity deserts. And there are these kind of pockets of high exposure that could likely warrant more mixed methods investigation. In terms of, we look at the distribution of these different exposure measures, we can see that the median value of the interaction exposure is about 0.44, which means there is on average a 44% probability that any two people selected within an interaction cluster are of different races. And this is actually still a lot higher than the residential levels. However, I think what's important to note is also the degree of overlap across all these three exposure measures as shown by the correlation down here. And we look at the correlation between the observed and the interaction to the residential exposure. And this suggests that the residential context still remains an important factor in determining exposures across a broad range of activities and contexts. And this is probably because residents extend their activity spaces most frequently to places in and near their home locations. When we look at the distribution of these three measures on a histogram, you can see that the red here is representing census data and residential exposure, and has a lot of mass near zero, which we kind of already knew from the city's spatial segregation. However, both the observed and the interaction exposures had the bulk of their mass closer to the maximum exposure value, which is 0.75. So again, I think this shows that the way that we're measuring residential, so the way that we're measuring social context and social exposure likely underestimates the actual degree to which people travel across space, and undercounts the degree of diversity that actually exists in the city. So this is what the interaction exposures look like disaggregated. And I was actually kind of curious to get some understanding of where these clusters are. And so here I've just selected some large clusters. And I think that it's not surprising that some of these are at airports and sports games or kind of high density residential areas, which I think actually points to a flaw in this method, which doesn't account for the z-axis distance. And also, not surprisingly, but under-researched in the segregation literature, I think, is the frequency at which I found clusters in retail spaces. So this is like a Costco and a Target and a Jewel Osco for the Americans amongst us. On the lower left-hand corner here is a shopping center, while you know, this is the water tower. It's kind of one of the main shopping malls in the city, and incidentally where I spent a lot of time as a teenager. And looking more closely at some of these clusters, you can kind of start to understand how they are spaces for potential social interaction. This is kind of a recreational beach. This is, I thought this cluster was strange, so I wanted to take a look at the street view, and it looks like it's a church that is maybe some kind of outdoors community gathering space as well. And, you know, and a lot of these spaces are at these shopping malls. So I found a lot of clusters in parking lots. So you can also argue that this is maybe another kind of weakness in the analysis, or I've like reached a limitation in the analysis where it's arguable whether or not, you know, parking lots or, you know, the fronts of these malls are spaces for social interaction, or people are just kind of sitting in their cars and they just happen to be close to one another. And lastly, I also wanted to look at the weekly temporal variation of the density and degree of the interaction exposure. And I think it also suggests another story and a possible source of social exposure. So here, when I look at the kind of the weekly breakdown, the exposure is generally higher during regular weekday hours, suggesting, and I think this is most consistently articulated in the morning hours, which might suggest that these exposures are happening during you know, workplace activities. So everybody goes to work, and that's kind of their secondary source of social exposure beyond the residential one. This monthly variation in social exposure, especially the reduced number of interaction clusters in October, which is this line here, also suggests a seasonality in these patterns and the sense and sensitivity of the exposure due to the weather, perhaps. Especially in Chicago, this can be kind of quite extreme. So again, like, here are the key takeaways. I think this study strongly suggests that there is a lot of value in using this dynamic data source as a complement to our existing understanding of demographic stratification and segregation. The observed exposure shows that the actual static social context in a neighborhood is much more diverse than what a residential context suggests. The interaction exposure, it turns out, is actually still quite diverse and not less than what is implied by the residential exposure. However, I think it's also interesting that the interaction tends to be more spatially heterogeneous. And then it's also kind of revealed these hyperlocal spaces of high exposure probabilities. Thus, I think the use of the residential exposure actually kind of like averages away the dynamic variability of exposure throughout the day. And I think May-Po Kwan has also kind of studied this question. And then, you know, and then we know that there's some kind of seasonality to these exposures that may or may not be related to weather, and this generally more higher exposure during the weekdays than the weekends. And one possibility of this higher interaction exposure might be due to workplace activities. Another might be due to the fact that we're simply not measuring some of these other types of spaces, such as like retail spaces. In terms of some of the caveats in this pretty nascent exploration, first, these are not interactions, but only opportunities for interaction. So the data is not like precise enough to know the exact location of where these so-called opportunities took place, or even if it was inside or outside. So making the connection between like specific locations and exposure is still tricky. Although I imagine that there can be more explorations connecting land use to variation in exposure. And I think partially due to these accuracy constraints, I see this work as really kind of complementing and not replacing existing quantitative measures using residential data and qualitative fieldwork. These measures, I think, can be a tool to help researchers hone in on particular areas of interest to be investigated further through other means. And then in terms of, there's a lot of next steps with this research, I think. For instance, you know, how does exposure differ for each group? Do white residents have more exposure than minorities, which is, I think, a conclusion that a paper by Mario Small and Rob Sampson concluded using Twitter data. What about race and class intersectionality? One way to do this might be to look at geodemographic profiles. So this image on the left here shows how, or on the right, I'm sorry, here shows how that clustering might look for Boston when I cluster education, race, and income. How does exposure change with different neighborhood types? Is interaction exposure less likely in gentrifying neighborhoods, for instance? And lastly, I think it would also be useful to consider exposure measures that are a blend of census and mobile app data, kind of given the continued importance of the residential context and the accuracy of the census data on certain levels. So that's it. I think I'm maybe done a little bit early, and I'll end here, and you know, we can have a discussion about this research. And I'm very curious to hear your thoughts and feedback about this work. Thanks.
Yeah, thank you very much, Wenfei, for this very interesting talk. Yeah, I think a lot of things are very richy, very meaty talking there. And please, everyone, can you please post your questions in the chat box, and so we can, boost our further discussions. So I'd like to go first. Actually, I find some seasonal difference in the exposure measures. So I'm just wondering, are these increase is driven by specific areas? For example, is it in the summer, is this kind of increase is driven by some, for example, beach or recreational sites, or it's just from a more spatially homogeneous increase?
Well, so short answer is I don't know. But if I were to speculate, I would assume that, you know, there's not going to be a totally homogeneous increase, right? Kind of when you think about, you know, a variation in activity as a consequence of seasonality, I would imagine that, you know, more people are outside and kind of in recreational areas. So I think there is probably kind of, you know, specific locations at which you'll see, you know, proportionally more activity, but I don't know in particular. That's a good question.
Yeah, thank you. So the people, thank you for this very interesting presentation. And Caitlin has a question. So Caitlin, do you want to jump in?
Yeah, thanks for the talk. I found it really interesting. I was just kind of thinking broadly about what the implications are of like the evidence of greater residential diversity are for like housing policy and the design of cities. Sorry, it's quite a big question to answer.
Yeah. So actually, thank you for asking that, because the origin of this, the origin of this study was in fact like my skepticism around kind of the consistent use of mixed income housing policy as our like main affordable housing policy. And if, you know, when you talk to affordable housing developers, when you talk to kind of people in practice, like there's this, you know, line, we need to deconcentrate poverty, and we need to kind of encourage social mixing. So when I started this research, I was really expecting to find that there was much less exposure, kind of using these very, using these very fine constraints of only 10 meters, or kind of only, 5 minutes between each ping. And I thought I would find much less interaction, but in fact, I didn't. So, in terms of what it means for housing policy in particular, I think it points to generally that we need to think more carefully about how we are measuring. I'm still not sure that there is, I think I've been very careful to talk about how I'm measuring kind of opportunities for interaction rather than specific interaction necessarily. And I think there's a lot more work to be done, kind of looking at, kind of how these exposures differ across different populations. But to me, it really points to that, the fact that, we need to improve our measurements for the implications of this policy, rather than just kind of assuming that like mixed income policy, mixed income housing will result in kind of social mixing.
Yeah, thanks for this. I think the next question from Alex. So the question is about, yeah, Alex, do you want to jump in? I think it's about how picking up race from the trace.
Yeah. Hi, Wenfei. Thank you for that great talk. Obviously, it'd be nicer if we'd seen you in person rather than virtually, but very good talk nonetheless. So I could have got this wrong, but I think you were picking up race of the different traces that you were looking at based on the probabilities of where their home locations are going to be. So you kind of ascribe the race on the basis of where they live. And I just wondered if you thought, if that was true, and I might have misunderstood, is there a risk there, particularly if, for example, different racial groups might access the technologies which are generating the data with kind of different propensity? And then I suppose the kind of follow-up, which you sort of touched on at the end, and something I probably should talk to you about anyway, is whether you'd actually thought about looking at it in terms of geodemographic mixing, so you were being more explicit about the characteristics of areas rather than individuals.
Yeah, so I think that's a very good point, and I think that is probably one area that can be explored further, which is what are the general, what are the general prevalences amongst different populations. And I think I showed that, at least kind of on the neighborhood level, there seems to be higher prevalence of use for these particular apps amongst Black populations, but also higher education populations. So at this stage of the research, I haven't accounted for kind of different prevalence of use, and I think that's something to kind of be modeled more carefully. But yes, and also I think that I've just looked at race, and what might be interesting is looking at other profiles and other characteristics in the census data.
Yeah, thanks for answering this. And the next question is from Andrea. So he asked about, did you measure how interactions are connected to patterns of consumptions? I'm not sure what was the definition of consumption. So Andrea, could you please just provide a little bit more about this question?
Yeah, sure. I was asking if the interaction you measure to cell phone data are somehow related, or you talked about how consumption is responsible basically for these interactions. And what I mean by consumption is that they're just people like buying things at the same place from different, I think, groups.
Yeah, so, kind of my less than kind of rigorous zooming around the map and, capturing large clusters, I think points to the idea that, which kind of we probably all know from our day-to-day activities, that there's a lot more, we spend a lot of time at stores, where we spend a lot of time shopping. And I think that, this is one aspect of kind of activity and potential social interaction that's not like properly captured in the data or in the way that we're measuring interaction or kind of social context now. But specifically, how much does consumption or how much do these types of spaces contribute to the degree that the interaction exposure changes, I think is it's a good next step. And I think I mentioned that maybe one of the next steps is to look at how land use patterns, how these different interaction exposures change based on land use patterns. So that's another dimension to investigate further.
So the next question is from Louis. So Louis, do you want to jump in? I think it's similar to Alex's question.
Yeah, it's similar to Alex's question. Thank you for the talk, first of all. I'm working on a very similar data set, and one thing that I'm quite concerned with mobile phone in-app data is sample bias, but especially in terms of people, like certain age groups that are underrepresented, or like Alex suggested, certain social groups. And I was wondering if your data also presents that type of population bias, how would you account for that in a wider analysis to extrapolate that to the Chicago scale and not just that population group? And do you have like, maybe there's a quantitative method to account for that? I don't know.
Sure. Yeah. So I think to first address the question of sample bias for perhaps younger or more educated populations in this particular data set. So first, I think that mobile phone usage is at this point very prevalent in most populations. In fact, there are studies that show that among certain populations, like like Black or other minority, or like low income populations, that their cell phone is their primary method of accessing the internet, rather than through like a computer or a desktop. So I think that you could, and as I mentioned here, that we actually see the Black population and higher education being positive predictors of the cell phone density. So I think, yes, in theory, there could be sample biases, but these can be potentially modeled. And what I've tried, and so I've tried to control for these when I ultimately am modeling population density through the cell phone data. And this is not very clear here, but if we look at using these particular features to model population density, that we produce an unbiased predicted population. In other words, the residuals are mean zero, and it looks here to be fairly, convincingly normally distributed. which is not to say that kind of on an individual block group level that there can't be bias. And I think that, you know, potentially, yeah. So I think I've been part of the, I think part of the main exercise of this paper has been trying to understand and trying to model that potential sample bias, because I just, like, you know, from my personal and previous work experience, have always been quite skeptical of this data given how noisy it is. So what I wanted to, part of what I wanted to do in this, you know, particular paper was to see if there was a way to find, to model and to kind of correct for some of the potential biases in the data.
Thank you very much. Brilliant.
Thanks for this. So the next question is from Danny. Danny, do you want to jump in?
Sure. Let me turn my video. And thanks very much, Wenfei. That was a super cool talk. I guess my question was more in the line of Kate's, that it's more broad about your views based on this study rather than the study in itself. But if I get it correctly, the main sort of takeaway message is that we mix up more as we go about our activity spaces in daily life than as the census would record in terms of residents, right? And the question then is this good? Well, good or bad is probably a strong word, but is this something that, or do you think that this shows that residential segregation is not necessarily a problem because at the end of the day, we all mix up anyway when we go about our lives? Or does this show probably more discrimination in residential markets than, say, on labor markets, for example, or on the location of labor, period? So it's a bit of an open-ended question, but kind of wide range.
So I'm still, you know, I'm still not convinced that this shows that there's less like segregation. You know, again, you know, potential for social interaction versus actual interaction. I think there was like a wide gap between those two concepts that, you know, I don't think this type of analysis can really start to address that question yet. I think, you know, in my fantasy research project, this is a mixed methods project that combines both, you know, census data and the cell phone data to identify potential areas where we think, okay, you know, this is there's like more diversity than what's suggested, and then we actually do you know, like field work to kind of understand kind of like the social networks and kind of like, you know, like the ecological networks that can actually compose the space. And so that would be one way of then kind of ground truthing some of these like fairly early findings. So I don't think it suggests at all that there is no, I don't think it suggests at all that there is no segregation, or that we should not kind of, you know, we should not have to kind of worry about residential segregation policies as much. I think that what I'm trying to do is to complicate our notion of what we mean by segregation if we actually want to think about these questions for particular policy purposes. That you know, that segregation is actually it's composed of the, you know, the actual social exposures that we experience on a day-to-day basis, and that is a different concept than kind of the more, I would argue, like fairly theoretical residential exposure that we are actually using for policy purposes. So I think I'm trying to kind of bring that, you know, make that distinction clear. If in fact, you know, we do care about, these concepts for actual, like, you know, policy or housing, actual housing policy. That makes sense.
Yeah, thanks.
So the next comment is from Patrick. So he mentioned there is a retail center boundaries for Chicago. There's a new paper about these. Yeah, Patrick, do you want to say a bit more about your very interesting work? Yeah.
Yeah, no problem. Hi, that was a really interesting talk. I really enjoyed that. Lots of food for thought. Yeah, I was just going to say, if you do decide, because I know that this probably won't be the focus of what you're doing, but if you do decide to explore kind of like what you found in relation to consumption, we've just finished a paper on retail centers in Chicago, and if you want to just do a kind of simple kind of overlay of kind of like maybe your interaction clusters with the kind of clustering of retail that we found in our study, that's something we could definitely look at, and it would be something that you could probably kind of, you know, do quite simple. But yeah, really interesting talk, and just, you know, if that's something that interests you, just get in touch.
Yeah, for sure. Reach out. I would love to kind of take this a bit further. I realize that there are kind of so many different directions that, or like next steps that I could take with this paper. I think I'm like the first paper was really just to kind of establish that, you know, it is like possible to use this data. But yeah, many different next steps.
The next question is from me. Sorry that I got so many of them. So I got 3 questions. So the first one is, have you found any specific race that suffers more of this problem
than others? Yeah, so I haven't yet looked at the breakdown for particular groups yet. I think that you know, I think you can decompose the measure quite easily to measure the specific, you know, so it's just, this is just a, yeah, so you can decompose this measure quite easily, but I would not be surprised if there is a difference of exposure across different races, just because it is a finding that kind of previous sociologists have found.
Great.
Yeah, and kind of similarly to answer your question about kind of decomposing this across different age groups as well, I think, yes, kind of these are all like, these are all possibilities. And do I think COVID has impacted interact? Of course. I think it would. I have a friend who is actually working with this with the cell phone data, and they have you know, they have like pre and post COVID data, and it's you know, it's very clear the distinction, you know, the difference, you know, between the difference in kind of activity pre and post COVID.
Yeah, I have the same feeling that the COVID might change a lot of these patterns, especially when this related to interactions, travels. Yeah.
Yeah, and I think what would be also kind of interesting to measure in a more like online way is kind of tracking how people, you know, post, you know, after we, you know, develop a herd immunity or become vaccinated, to kind of track how people gradually go from a no interaction context or kind of way of like existence, how we kind of gradually move to kind of more interaction, and what types of interactions or exposures we're willing to we're willing to expose ourselves to in kind of like the post-COVID context. So I think, you know, that would be like a really cool you know, thing to measure on an ongoing basis.
The next comment is from Leo, and suggested his work about social mixing in I think it's markets, shopping malls. It's quite similar. It's similar methods. That is quite interesting.
Oh, great. I will check it out. Yeah, this is not the first social mixing paper using, using GPS data, but I think that what's unique about the mobile application data that's kind of different from previous cell phone data sources, in particular like CDR data, is just that it's much more, it has a much higher accuracy. So CDR data has like an accuracy of 300 meters or so, and this, the mobile app data, as I kind of mentioned in the beginning of my talk, the median accuracy is like 12 meters. So it really allows you to then, start to kind of conceptualize like actual interaction between two people or multiple people in a group, rather than kind of aggregate everything to an administrative boundary.
Sure, I'm going to jump in. I'm sorry, I'm Leo. Hi.
Hello.
That's correct, except that we work with the antennas inside the malls, let's say. So it's not that we don't know. I mean, we know where they're coming from, and we know that they're inside the mall because all cell phone antennas in very big places are just indoor antennas. You're not connecting to the general antennas of the city, let's say. But so you can actually tell which floor you're in and so on and so forth as well.
Oh, cool. Yeah.
So, and this is XDR. This is not CDR. This is like an intermediate, more granular in time, let's say, than the CDR. CDR is calls. This is data. But anyway, it doesn't matter. It's excellent talk. Thank you.
Okay. Yeah, I'll take a look at the paper. Thank you for sharing it. And just actually, just out of curiosity, what did you find in the shopping mall context?
So technically, we used some gravity and entropy and stuff like that, and then we said, okay, so where do people come from in the different comunas of Chile, and then which malls do they go to? And basically, we found that if you had to choose which malls you go to those that are more socially mixed, even if there are others that are closer. So that's what we. So basically, it's more or less in keeping with your idea. Let's say it's like, I mean, there is more social mixing. If you have to choose, you don't really care so much about distance. You care that the mall is more mixed. I mean, I don't know if there are causality there, but you go to malls that are more socially diverse than.
Yeah, one thing I was thinking about. Yeah. So one thing I was thinking about, like, right before the talk, is that, obviously the degree of mixture has to do with the number of people, right? And so I wonder if, in measuring kind of exposure, like, the degree of mixture, you're actually just kind of measuring some, proxy for like, for counts or volume.
Correct. And I mean, interaction is very hard to measure, right? I mean, that you co-occur with someone doesn't mean that you're interacting with that person, right? It's just that you're in the same, more or less in the same physical space, but that's it, right? Right. So here we have an underdeterminacy of the data, in the sense that, I mean, there's no way to know if they're actually interacting. We know that they're spatially co-occurring, and that's it.
Right. Yeah, exactly. Yes, yeah. And
thanks, Leo. Yeah, it's very interesting. I think it's quite different perspective, and very interesting. The next comments from Bob. Bob suggested a retail analysis and open data company that probably we're going to be interested in. I think this is very helpful. So yeah, thank you very much, Bob. So
sure.
Thank you. So do we
Yeah,
have?
yeah.
Please.
Oh, I was just gonna say, yeah, of course I've heard of geolytics.
Yeah. Thank you. So do we have any other final questions? I see Sarah's, yeah, Sarah's thanking you for this very good presentation. Yeah, thank you very much. Okay, so
Yeah,
so if there is, sorry, I got some lag. Sorry, I got some lag. Yeah.
Yeah. Sorry about that. I was gonna say the paper is under review right now. So I'm happy to share drafts individually if you email me, Sarah, and anybody else wants to take a look.
Okay. Yeah, thank you. So if there is no other questions, I'd like to thank Wenfei again for this very interesting talk and the very insightful discussions with the audience. So I would also like to announce that the next Brown-Beck seminar will happen in March 25th. It will focus on spatial data science and sustainability. So thank you very much all, and thank you very much Wenfei again for this very good presentation with us today. Thank you.
Yeah, thank you for the invitation. This is great.